Hello everyone, welcome back to Reverse Engineering Linux 32-bit applications. In this video, we're going to continue our discussion of format string errors. And we're actually going to wrap it up in this video. We've been talking about this for a little while. And in this video, I'm going to show you how you can write to arbitrary memory locations. In a previous video, we showed you how you could read any old memory location. Now I'm going to show you how you can write to essentially anywhere that's writable, at least. Of course, if you try to write to some place that's not writable, you're going to get a segfault, access violation. Okay, let's get started. So, I'm going to go ahead and bring up my slightly more complicated format string program. And again, we introduced this before just because it was more convenient than using argv directly in our call to printf, is that put it just further down in our stack. We could have done it this way, but with our nice optimizing compiler, this is just a little bit more convenient to do it. All right, so here we are, and we have our program once again. So let me run my program. I'm going to run it through EDB, and I'm going to do something similar to what I did before. So here's what we did before. I'm going to go ahead and just run this real quick and verify that this does what I expect it to do. And in this case, I'm just going to run it and let it run to the end. And as we saw before, I was able to print out this particular memory location. So here's what we want to do differently. We're going to use the %n. Now remember, the %n format specifier will write the number of characters written to a location. So how does that work exactly? If I wanted to do it legitimately in my program, I would do something like this. I would print, and if this format string included %n, then I would pass in an address for this parameter. So it will look something kind of like this. I would have an integer of some sort, and I could call something like the following, where I'm printing this is what is printed %n, and then I would give it an address of some sort of a counter, where I previously defined this counter as an integer. So that is how you legitimately use %n. So what we're going to do is we're going to use %n, and we're going to use it in order to write to a particular location. And we're going to change a value in that location. Now, here's the hard part. it's hard to put an exact value in that location because it's going to count the number of characters that were output. And that's going to depend on things such as the number of characters in your format string, and how many items did you print out, and all of that. So this does work, and you can write an arbitrary location. It's just not terribly easy to write an exact value. You can do it with a little work, and we'll see that here in a bit, but it is not the easiest thing to do. Okay, so enough of that. I'm going to go ahead and just revert this file. Because I don't need to make that change here. So we'll start with this. What if I change this last %s to a %n? Let's see what happens with this simple change. We'll step through it and see if it does about what I want it to do. So I'll go to my breakpoint. We'll go ahead and step forward. And now we're getting ready to call printf. So what do we have on our stack? We have some memory locations. And if I scroll down here, sure enough, I see 080485E0, which is the location of this string. So that's great. And it should be in the same location as before. So let me go ahead and boldly step over this. And it's going to give me a seg fault. And why did it give me a seg fault? It said you tried to write to this location, and that location couldn't be accessed. So we did everything exactly the way we wanted to. The only difference is we wrote to a place that we couldn't write to. So what can I do about this? Well, what I could do is I could look at these different memory segments. And here I have my text segment, if you will. This is my code segment, readable and executable. I have this segment. This is only readable. This is where I store any constants in my program. And here is where I store other variables. It's readable and writable. So what do we find in this region? Well, let me make a small change to my program, and I'm going to introduce a global variable. And then I'm going to try and change it. So let me go ahead and close this. And I'm going to close out EDB for now. And I'm going to go here. And I'm going to save this as a new name. And And I'm going to create a new string, happy. And I'm going to make this a 20-character string. And now I'm going to go here and I'm going to set happy. I could set it outside of this, but just for grins, I'm going to set it here. And I'm going to say stir copy to happy. I am happy. I'll save that. I'll go ahead and build it. And I'm going to run my new program through here, and things aren't going to line up. So I'm going to have to make some changes anyway, but let's just start here. And I'll go ahead and set my breakpoint. Okay, so now what do I see? I see a couple of things. Once again, if I look on my stack, I will see this address at the appropriate location. But what I want to do is try to figure out how to change something that I actually can change. You know, don't waste your time trying to change things you can't change, right? That's kind of a general rule in life. So now if I go back here, notice that at this address, 040804A030, I have my string happy. So I'm going to take that address and I'm going to make a note of that. And I'm going to try to overwrite that address with my program. We'll see if I'm still lined up properly. I'm just going to hit F9, let it fly, and sure enough, I am. So none of that alignment changed, which is good. So now what? Let me go ahead and stop my program. Going to rerun it, but now I want to go to 0804 A0 and the last byte I have as 30. So I'm going to go to 30 A0 0408, which is correct, I believe. So let's try this one again. I'll run to my breakpoint. I'll step ahead. All right, moment of truth. So if I look at my stack, you'll notice that I now have the address of this string happy. I'm going to boldly step over this. Nothing bad seemed to happen. And let me do this. Let me view this region. And sure enough, what do we see here? Happy has been overwritten. So now I have this value, 1C000000. Okay, so that's how many characters were written out, 1C. And I was able to write to an arbitrary memory location anything that's writable. So that's pretty cool. I'm able to write a value. Now, a couple of things about this method. Number one, I was able to write multiple zeros. Well, that's pretty cool. Normally, writing a null byte is difficult. But in this case, I was able to write 3 null bytes. Now, what if I wanted a particular value in this location? How can I do that? Well, the way you do that is to use things like zeros, leading zeros for numbers, and other format specifiers. You can add in new lines. There's all kinds of things you could do. So let's just say that I wanted this value to be higher. So how can I do that? Maybe I wanted it to be 20. I just need to add 4 characters to my string. Of course, the easiest way to do that, if this is all that I'm doing, is to do something like the following. So I'm going to go ahead and stop this again. And now I'm going to say, all right, I will print A, B, C, D. Let's see what this does. Run to my breakpoint. Step, step, step. Here I have ABCD 0. I still have this location. The only question is, will it be where it needs to be, or did I just move it? And we'll have our answer right there. And the answer is, I just moved it. Notice it complained. It said, whoa, I can't go here to A, B, C, D. So how do we fix this? Very simple. Let's print that somewhere else. So now I'm going to take my string that I'm passing, I will add A, B, C, D to the end of that. All right, so now I'm pointing somewhere else. Still have my pointer to my string happy. Let me boldly step over it. Nothing bad happened. Let me view my memory region. Here it was. And success. I now have 32 or hex 20 in that place. So you'll see with a little work, you can put a particular value into a location. Now, if this was 64-bit Linux, this would be really, really hard. But for 32-bit Linux, this is doable. You know, Linux programs will accept large command lines, which is not the case for Windows. So there's some more limitations with Windows for doing things like this. All right, so just to sum up real quickly, we talked about format string errors in this last set of videos. We said that if you have usage of a function such as printf, and that's not the only one, it's one in a family of functions that accept multiple arguments where the first argument can be a format string. So if you use these and you just assume that the only argument isn't a format string and the user has control over what flows to that function, you could have a problem. What kind of a problem? Well, he said a bad person could crash your program. Super easy to do. They could also leak information off of the stack. That is somewhat easy to do. We showed you how they could view arbitrary memory locations. And in this video, we showed you how you could modify arbitrary memory locations. So all of these things you can do from one simple little error that looks like that. So that's huge. You know, if you think about it, whoever was the first person to say, hey, look, this is a security problem, hats off to that person. You know, obviously pretty smart and had some creative thinking there to realize that this could be a problem. It's part of the hacker mentality, right? When programmers make things, they don't ask questions like, what could someone possibly do? They tend to be more of the philosophy of, why would anyone do that? Why would anyone try to break this program? Most of the time, people are supposed to be trying to do what the program is helping them do. So that wraps up our discussion of format string vulnerabilities. I hope you're enjoying this course so far. We still have lots to go, even though we're something like 11 hours into it already. I'm looking forward to continuing this discussion of reverse engineering with you. And just as a reminder, this video is one in a series of videos and courses that we have here at Pen Tester Academy, your source for everything InfoSec. And I look forward to seeing you in this course or another course soon. See you then.